Welcome to this video. I'll be going through the 2024 paper number 2 from Edexcel. Now, these are my own solutions and they will be uploaded 1 year after the exam has been sat, so not to infringe upon any exam board regulations or anything like that. One thing worth remembering is wherever you are in your journey, whether you're preparing for your GCSEs or have GCSEs this year itself, I'll be going through the solutions in such a way that I won't just be teaching you how to answer this particular question. Where I can, I'll be giving you extra bits of information. So should you see similar topics or similar questions come up in the exam, in your exam, you will be better prepared for handling it. So let's go. Let's proceed with the very first question. We have a nice and easy one. We've got ABC is a right angled triangle. We've been asked to work out C to B. Often students get confused when they see right angled triangles. And I'm not talking about the higher students, the ones in the middle ability sets. They don't know what to use. They start using Pythagoras, trigonometry. They don't know. Okay. So look, when you have a right angle triangle, it's only Pythagoras or trigonometry. And if you've been asked to work out a length given two other lengths, so you've been asked to work out CB and you've been given two lengths, it's Pythagoras. Okay, there's no angle in the diagram, so there's no scope here for trigonometry at all. Okay, so if you see an angle, then you can start thinking about trigonometry, the SOHCAHTOA. Okay, right, so we are going to be using Pythagoras. What is Pythagoras? It's a squared plus b squared equals c squared, with c being the most important side. Students often get confused. You know, they see some diagrams where C looks like it could be this side or that side. But just remember, the hypotenuse is your C, and it's the longest side, and it's always opposite the right angle. So that's the first side that you need to label correctly. A and B can be any of them, okay? So we can call this one A and this one B, or vice versa, all right? Now, put into our equation now. So A squared, A, which we don't know, it is CB. You can write CB squared if you want to, or just write A. Or x if you label the x. B is 10, so 10 squared, and C is 19 squared. Remember, you can use a calculator, all right? So I've done these calculations. I just won't do the calculator right now. I'll just take my solutions, okay? So CB squared plus 100 is equal to 19 squared. That is 361. So we take the 100 to the other side now. So we have CB squared is equal to 361. Take away the 100, and CB squared would equal 261. Now, you don't want CB squared, you want CB, so you got to square root your answer, 261. The square root of 261 to three significant figures, you get 16.2 centimeters. All right, that's your first answer. Next, question number 2, write 90 as a product of its prime factors. So you want to break up 90 by prime numbers. Prime numbers are numbers like 2, 3, 5, 7, 11, so on and so forth. So the smallest prime number, you can use 2 or you can use 3 in this example. Let's use 3. So 3 times what gives you 90? 3 times 30. Circle the 3 because it is a prime number, and then continue breaking up the 30. You could break it up by 3 again, so 3 and 10. Circle the prime number, break this up. This one is 2 and 5, and they are both prime numbers. So to write as a product of its prime factors, we have to write them in order. So 2 times by 3, times by 3 again, times by 5, and that becomes 2 times 3 squared times by 5. That's your answer. But the examiners will also accept this as well. So, yep, that's done. Right, next, it says write down the lowest common multiple of A and B. There's a few ways of doing this, but I tend to draw a Venn diagram. Okay, so I have two circles, circle A and circle B. Let's label that A and B. Now, let's break down circle A, or A. We've got 2 squared, so that's 2 times 2 and then 3. And for this one, it's 2 times 3 times 3. Now, what do they both have? They both have a 2 at least. That's going to go inside there, 1, 2. And they both have 1, 3 at least as well. So 3 is also going to go in the middle. Now, if you look back at A, what's going to go just in A only? Okay, so just in A. So we've got the 2 and the 3 already. So an extra 2 is going to go just in A. Okay, there. Same thing for B. We say what's in B. So we've got the 2 and the 3 already right there. So an extra 3 is going to go just in B right there. That's your Venn diagram done. Now, LCM is simply all your circle, all your parts. So this part times this part, that times this part. That is your LCM. If you are asked to do HCF, it will be this circle, and it would just be the middle that you take. Okay, but you've been asked to do the LCM. So it's going to be 2 times 2 times 3 times 3. All the numbers, that times that times that times that. Okay, so start with the biggest one. Oh, you have a calculator, so you can just put that into your calculator, and whatever answer you get, 36. But 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. All right, and if you were asked to do the HCF, it would just be 2 times by 3, which is 6. So the HCF in this question would be 2 times by 3 equals 6. Okay, and that's how you find the HCF. Right, moving on. Question number 3. So the number of hours H that some machines take to make 5,000 bottles is given by H is equal to 72 over N, where N is the number of machines. On Monday, 6 machines made 5,000 bottles. On Tuesday, 9 machines made 5,000 bottles. The machines took more time to make the bottles on The machines took more time to make the bottles on Monday than on Tuesday. How much more time? Well, H is the formula that you're going to use to find out the number of hours it took. So if we take Monday, we know that 6 machines were used to make 5,000 bottles. So H would be 72 divided by N is the number of machines, so 6 machines. So that would be on your calculator 72 divided by 6, which is 12 hours. So that's on Monday. On Tuesday, H was how many hours it takes. So you had 72 divided by N, which is the number of machines, 9. So 72 divided by 9, that is 8 hours. Well, the gap between them is 4 hours. Okay, so there you go. How much more time was taken? 4 hours. There you go. Well, it should be the other way, by the way. It should be that way. Yeah, so just don't look at the arrow. It's just to show you the gap between them. All right, question number 4. There are only red disc, blue disc, and yellow disc in the bag. There are 24 yellow discs in the bag. Okay, Mel is going to take out random a disc from the bag. The probability that the disc will be yellow is 0.16. And we also told that the yellow discs, there were 24 of them. That means we can equate 24 yellow discs, or 24 discs itself, is equivalent to a probability of 0.16. Okay, that we can just make that statement. The number of red discs to the number of blue discs is in the ratio of 5 to 4. We want to work out the number of red discs. So let's work out what the total number of discs is. And to do that, all probabilities are out of 1. Okay, so we need to somehow go from 0.16, maybe go to the middle, and then go up to 1. All right, that's something we need to do. So, or we can, because we've got a calculator, and calculator can be powerful. How do you make that into 1? By dividing by 0.16. So if you do 0.16 divided by 0.16 is equal to 1, because anything divided by the same anything is 1. So we just need to divide the other side by 0.16 as well. So if we do 24 divided by 0.16, we get, I'll do it? Yeah, 150 discs. So in total, we have 150 discs. Okay, that's the total number of discs that we have. Now remember, 24 of those were yellow. So if we do 150 minus the 24, we get 126. So that means 126 discs are the other colors, which is red or blue. So we need to divide the red and blue ratios, 126 into that. Okay, so we can do 5 plus 4, which is 9 parts. And do 126 divided by 9 using our calculator, and that gives us 14 discs in each part. So we can put them in the ratio now. So red and blue. We just want red, don't we? Yeah. So the question just wants red, which is 5 parts. So we don't need the blue. So the red would be 5 parts. So therefore, it will be 14 times by 5, and that is 70. So you've got 70 red discs right there. Okay. All right, moving on. Question number 5. So on the grid, okay, draw that graph. But first, you've got to do the table. Some students struggle with negative numbers, all right, when it comes to negative numbers. You might think it's just a simple matter of putting into your calculator. Sometimes it can appear on calculator paper, by the way. Yeah, but yeah, just be careful. Use brackets, okay? So for this and this, we need to know that the x value is going to be -1 in here. We'll get the answer here. And then for the 1, it's going to be a positive 1, all right? So if we put that into a calculator, we have bracket -1 squared minus -1, that's 2, so it gives us the answer of 2 here. And then we put the 1 in. You could do them in your head as well. So bracket 1 squared minus 1, there you go, 0. Okay, so now we're going to plot this. So the first plot is -2 and 6, so x is -2 and y is 6. Okay, so that's our first plot right there. Next one is -1, 2, right here, 0, 0, 1, 0, 2, 2. Oh, we haven't done the 3 yet. Okay, let's do the 3. So that will be 3 squared minus 3, 6. There we go. So that's 3, 6 right there. Okay, so quadratic graph. So there. Now I want to show you something here. Very careful. Okay, this is how it should look, something like that. It's this part. A lot of students, they come down here and they draw a flat line going up there. Please don't do that. You need to make sure that it dips a little bit. Usually exactly halfway, that dip will start turning back again, okay? So just have a little dip. Show the examiner that you understand that it's supposed to have a dip. Not like this, yeah? Not like that. This is not what not to do. The way I've done it is what you need to do, okay? Yeah, there you go, done. Right, then it says use your graphs to find an estimate for the solutions. Now, what do you notice here between what you've been given? Can you see that you've got this 4, all right, and this y? So you've got another graph here, which is a y equals 4 graph, okay? Because the y has been made equal to 4. So what does a y equal 4 graph look like? It's a straight line, okay? So straight line at where y is always equal to 4. A lot of people think that y equals 4 line or any y line is going up. It's not. It's this way, okay? Because it means that y is always 4. On this line, y is always going to be 4. All right, so it's like that, not like this, okay? That's x equals 4. All right, so where do these graphs meet is the solutions, okay? Because they're equal to each other. Where does the quadratic graph, this one, which you've drawn here, and the line y equals 4, where do they meet? They meet here and they meet here. So I'm just going to highlight. They meet here and they meet here. Just go down and give the solutions, which is your x value. So this is your x value. So x is equal to 2.5. And this is another x value where x is equal to minus 1.5. So the answers would be x is equal to minus 1.5 or x is equal to 2.5. Okay, they are your two solutions. And the examiners will give you some discretion on this because it depends on how you've drawn it. Okay, so some of you may have drawn a little bit like that, and there'll be a range. Okay, so it won't be precisely this, the answer. It'll be a little bit off, and you're fine. Okay. Right, next, Andy, Luke, and Tina share some sweets in the ratio 1, 6, and 14. Tina gives 3/7 of her sweets to Andy. So Tina, who is currently on 14 parts, gives 3/7 of that to Andy, which is this. Okay, so he gains. Then Tina, gosh, Tina is generous, isn't she? Tina then gives 12.5% of the rest of her sweets. So what she has left after she gives it to Andy, to Luke. So Luke is in the middle here, he gets some more. Tina says, now all 3 of us have the same number of sweets. Is she correct? You must show how you get your answer. Let's work on Tina first. So first of all, what's the total amount of ratio? Some of you might look at stuff like that. So, you want to add them or not. Yeah, you can add. There's no harm in doing that. So if you do 1 plus 6 plus 14, it's 21 parts. Yeah, so we've got 21 parts in total. If that's useful for you, yeah, that's fine. But we know what Tina's giving away. It's Tina that's giving away from her 14 parts. So we want to work out 3/7 of 14 parts. That's the most crucial part. So how do we do that? We've got calculator, so we can just make this into a time sign because of means times. So we can do 3/7 times by 14. And what do we get? We get 6. So 14 divided by 7 is 2 times 3, 6. So 6 parts. That's the amount that goes to Andy. Remember, it's in parts. So Andy used to be 1 part. Now Andy has gained 6 parts. So now we can say Andy now has 1 plus 6, which is 7 parts. Now, what does Tina have left? She's given away 6 parts to Andy. She used to have 14 parts. So we're going to do Tina left 14 minus 6, which is 8. So she has 8 parts left. Now, from this, she then gives 12.5% of the rest, which is these 8 parts, to Luke. So we need to work out 12.5% of 8 parts. Okay, that can be done using the multiplier method. So 12.5% as a percentage multiplier is going to be 0.125 times by 8. So if we work that out, 0.125 times by 8, we get 1. Okay, so she gives 1 part to Luke. So Luke now has, from his 6 parts, remember Luke was equal to 6, he now has gained a part. So Luke has 1 extra part. So 6 he had, so let's start with that. 6 plus the 1 extra that he's got. He's also got 7 parts. Now, if Tina has given away 1 part to Luke from her remaining parts, she now has 7 parts, doesn't she? So Tina now has 7 parts. So Tina has 7 parts, Luke has 7 parts, and Andy Pandy also has 7 parts, which means that they all have the same number of parts. So therefore, they'll have the same number of sweets. So yes, Tina is correct. Yes, Tina is correct. They all have the same number of sweets. Question number 7. ABCD is a quadrilateral. All angles are measured in degrees. Show that ABCD is a trapezium. Now, what do we know about trapezium? Let's focus on that first, because I know a lot of you are going to be thinking 360, all the angles, yes, add up in a quadrilateral to 360. But more importantly, you have to show it's a trapezium, because quadrilateral can be trapeziums, it can be rectangle, it can be square, it can be kites, rhombus, all sorts. Okay, so we have to prove trapezium. So the most important thing to understand about trapezium is there are two types of trapeziums, like this or like that. But what do they have in common? The fact that they have two lines which are parallel. That's it. Okay, so we have to just prove that this line is parallel to this line. Okay, that's the thing. How do you... Now, that should really jog some of your memory. Okay, we're talking about two lines which are parallel, a line coming through the middle. We're talking about corresponding alternate. Yes, we are. We're talking about these rules. How do we show? What rule is that? We've got things like corresponding alternate, obviously Z. So this angle here is the same as this angle here, the same. But obviously we haven't got an angle like that. We don't have this angle and that angle. Yes, they are the same. Okay, we have to prove corresponding. Okay, so there's another rule, which is the co-interior. We know that the co-interior angles, what happens? They add up to 180. So if we can prove that these two angles or these two angles add up to 180, then we have proved that this line and this line are parallel, and therefore we have a trapezium right here, a trapezium quadrilateral. So where do we begin for that? We can't just say this is equal to that. Sorry, not this. We can't just say this plus that is equal to 180. That's you forcing it. Okay, you assumed that these are parallel, but we're not. We have to use the rule about quadrilaterals, about all the angles in a quadrilateral are up to 360. So we have to start there. Find x, substitute x back in here, know what this angle is, and then we can add them up and say, look, they both add up to 180, therefore they are co-interior angles, and therefore these are parallel lines. You understand? Okay, so let's go. So we know 4x plus 15 plus 4x. I'm going across, yeah, adding that, then adding that, then adding that. Okay, you can do in a different order if you want to. So plus 3x minus 3 plus 2x plus 15 is equal to 360. I know that for a fact because I've been told that this is a parallelogram, okay? Sorry, not parallelogram, quadrilateral. Hold on, what's going on my screen? Oh, sorry, okay. My screen went off, so I just had to restart things. Okay, so add up all of the like terms, 4x, 3x, and 2x, that's 5, plus 8 is 13. So we got 13x, add the 15 and the 8, and so we've got 15, 8 minus 3 plus that is 35, and equals to 360. Take the 35 to the other side, so 13x equals 325, and then divide by 13, so 325 divided by 13, x is equal to 25 degrees, or forget the degrees actually, just 25. Okay, x is equal to 25. Right, so now let's just take any of the two, this one and this one I'm going to go for, yeah? So if we look at 4x plus 15, let's see what that gives us. So 4 times 25 plus 15. 4 times 25 is 100. 100 plus 15 is 115. So this angle right here is 115. Now we're going to do the 2x one. So the 2x plus 15 one. So 2 times 25 plus 15. 2 times 25 is 50. Plus 15 is 65. Okay, so this angle here is 65. Now, do they both? So if this is 115 and this is 65, is 115 plus 65, what's that equal to? It's equal to 180. So 115 plus 65, it is indeed equal to 180. So therefore, co-interior, and therefore they are parallel lines, and therefore it's a trapezium, because trapeziums are the quadrilateral that has two lines parallel. Okay. All right, question number 8. A playground is in the shape of a right angle triangle. Dan makes a scale drawing of the playground. He uses a scale of 1 centimeter to represent 5 meters. The area of the playground on the scale drawing is 28 centimeters squared. The real length of Q to R, so Q to R is 40 in real life. Okay, so in real life this is 40 meters. Work out the real length of P to Q. P to Q is here. Okay, right. So, okay, we've got area. Okay, what we can do is use that to work out base times height divided by 2. That's the area of a right angle triangle. Okay, so that will allow us to work out PQ. Okay, PQ being the base. Okay, so if you have base times the height, which is 40, divided by 2 is the area, which is 28, given to us. So we can just divide this by 2, by the way. So we get 20b is equal to 28, or if you can times this up here as well. So you can have either way, whichever way you decide. So therefore b would be equal to 28 divided by 20. So 28 divided by 20, that is 1.4. 1.4 meters. Okay. Now, okay. Did I get that correct? 40 divided by 2 is 20. And 28 times by 2. Damn. All right. Sorry. All right. So now you've got 20b right here. Now, there's a problem here, guys. There's a problem here, right? See this 28 is in centimeters squared. But this 40, you're using meters, all right? So you've got to be careful here. So you can't use this version of it, okay? Be very careful. I did that on purpose, all right? So, well, all right, fine. I walked right into that, then I noticed it. Okay, so what you want to do is either go back to this is the simplest way, just convert that into centimeters, okay? Although we are looking for the real length of PQ. So in centimeters, this would be divided by 5. Okay, so 40 divided by 5, 40 divided by 5 is 8. So it's got 8 centimeters. So here you'll come back here and say the height is 8. Now this 8 divided by 2, that's 4. So you get 4b is equal to 28. And then b would be equal to 28 divided by 4. And b would be equal to 7 centimeters. Right, so the base is 7 centimeters, but we need to go back to the real length of PQ, so times it by 5. Okay, so the real length, because every centimeter is 5 meters in real life, so the real length of PQ is to do 7 centimeters times by 5, and 7 times 5 is 35 meters. So in real life, it's 35 meters. All right, question number 9. A number is rounded to 2 significant figures. The result is this. Write down the possible value of n. Right, in the middle, 7.3. I know some of you will know the answer straight away, no problem. Okay, do that. But I'd like to show you more than that. So 2SF, this is a second significant figure. So go up one more there and behind one more there. So up is 7.4, behind is 7.2. That's not your answer though. The lower and the upper values are here, bounds. Yeah, so that's going to be halfway between 7.2 and 7.3, which is 7.25, and halfway between 7.3 and 7.4 is 7.35. So you ask for the least possible value, so it's going to be 7.25. Now, Layla says the value of n cannot be greater than this because 7.350 would round up to 7.4. Is she correct? Well, there you go. It can't be greater than that. Okay, that's what you should be saying. So it can't be greater than that. It can be that. Okay, so she is wrong. Okay, because look, what should I say? Actually, it cannot be greater than 3 point. Hold on. It cannot be greater than 7.34999. We can have loads of 9. So this number is bigger than that number. All right. So that's why when we do this, when we usually do these questions, we add a less than only on that side. Okay. So if we say something like number n is 7.25 as our lowest number and 7.35 as our biggest number. That's what we normally do. And because this sign is there, it means it can't actually be equal to that. So anything just less than that is like a number like this. So is Layla correct? No. Layla is wrong. Layla is wrong because we can have a bigger number than 7.349 that she stopped at because we can have more 9s afterwards. So we can have this number. This number, if you round it to significant figures, which is right here, this number won't make this into a 4. Okay, so yeah, Layla is wrong. Question number 10. The diagram shows 2 right-angled triangles. All lengths are measured in centimeters. So given that sine A is equal to tan B, work out the value of x. Right, so this is a trig question. Why do we know this? Because it uses angles. So we can write down our we can write down our SOHCAHTOA right there. So if we label the diagram, this is our, oops, wrong way. So this is our hypotenuse, this is our opposite, okay, because opposite the angle. This one, this is our adjacent, this is our opposite. So if we look at the first diagram, we have opposite and hypotenuse, which is using sine. So it's going to be sine of this. So sine A is equal to opposite, which is 7 minus 2x over 8. And for the second one, this one right here is opposite and A, which is this one here. So it's going to be tan B is equal to 1 plus x over adjacent, which is 4. So now we are told that sine A is equal to tan B. So that is equal to that. So therefore, this must be equal to that. So therefore, 7 minus 2x over 8 is equal to 1 plus x over 4. Cross multiply this and find the value of x. Let's do it down here. So 7 minus 7 minus 2x times by 4 is equal to 8 times 1 plus x. 4 times 7 is 28 minus 8x. 8 plus 8x, take the x's to one side. So take this minus 8x over to that side by adding. And we get 8 plus 16x is equal to 28 there. Take the 8 away from both sides. So 20 minus 8, 28 minus 8, yeah, 16x. And then x would be equal to 20 divided by 16. We can use our calculator to find the value of that, which is 1.25. It is a calculator paper, saves us time. So there you go, x is equal to 1.25. Okay, next question. We have cumulative frequency table, okay, which is simply cumulative frequency means to add up the frequencies. So the first number that goes here is 7. Put 7 there. You've got 7. Now you add the next frequency, which is 21. 7 plus 21, that is 28. Then you add 28 to 15. 15 is 43. Then add the 11, which is 54. Add the 6, which is 60. If you've done this right, it would always equal what you've been given, okay? Right, on the grid opposite, obviously it means like it's a paper. It's on the other side. Draw the cumulative frequency. All right, so right here. Now I just want to quickly show you something. The 7, the 28, the 43, where do they get plotted? Does that 7 get plotted above the 2, or does it get plotted above the 0? Or does it get plotted midway? These are some of the questions students ask themselves in exams. Cumulative frequency plots against the upper value. There is another diagram similar to this where you draw stuff like that perhaps, but it gets plotted in the middle. Can you tell me what topic that is for? What would be the graph for that? Okay, so in the comments, question 11, it's part A, say the answer. Okay, I want to know what your answer is. So what topic do we plot 728 on the midpoint of? All right, if you know the answer to that, in the comments, please. Okay, but let's continue. Anyway, so here we'll be plotting the 7 against the 2, the 28 against the 4, so on and so forth. All right, so it's all done for us. So 7, 2. Okay, so look, let's go up here. We have to see where the 7 is. 1, 2, 3, 4, 5, 6, 7 right there, and the 2 right there. Okay, so x there. Next one is 28 and 4. So 28 and 4 there. Next one is 43 and 6 right there. Then we have 54 and 8 right there, and 10 and 60 right there. Okay, that's messing me around again. Okay, 10 and 60 right there. Now, they have, examiners, back in my days, we had to draw this freehand like that. All right, but examiners these days, they allow you to get your ruler and join them up like that. Yeah, so you're kind of lucky, But yeah, we had to just like that. That's terrible. Let's do that again. And that's probably why the examiners allow you, because if you're terrible, like what I was doing, then yeah, look at that. That's a bit dodgy here. I don't like that, but you get the picture. Yeah, that'd be fine. Though. All right, moving on. Right, use your graph to estimate the interquartile range. What is the interquartile range? The interquartile range is the middle 50%. So it's your upper quartile minus your lower quartile. Yes, your upper quartile minus your lower quartile. The upper quartile is your 75% or your 3/4 minus your lower quartile, which is your 25% or your 1/4. So you want to find where the 3/4 and the 1/4 of this data is. So 60 is the full, halfway is 50, 30, right? And half of 30 is 15. So that's the first quarter. And then if you times that by 3, you get the half of between 60 and 30, which is there, 45, okay? So you just need to go and read those numbers now. So that's the first quarter, is 15, yeah, we said. So there, and that's why your graph needs to be good. Right there, yeah, something around there. So what is that value? So if that's 3, that's 2.2468, yeah, that's 2.246, 2.6, okay? And then we'll do the same thing for the 45 as well. Go across, hit your graph. Okay, that kind of hits in the middle. That's probably because I could have done a better one there. So let's just go there. Okay, it doesn't matter. It's an estimate. If you remember, the question said estimate. All right. So I'm just going to go a little bit out there. Okay, and that would be 6.2. All right, so now the gap. All I'm doing is finding the gap between them, and that would be the estimate for the interquartile range. Okay, so therefore it would be upper quartile, which is 6.2, minus the lower quartile, which is 2.6. I can use my calculator here. So 6.2 minus 2.6, and the answer is 3.6 kilograms. Okay, again, there will be a range for you in the exam, so don't worry. I mean, when I did this question earlier, I also got 3.6 as well. Yeah, but the examiners will allow a range from 3.4 to 4, something like that. Right, then it says use your graph to find an estimate for the number of these parcels with a weight greater than 7.4. So if you go back up to your diagram, so you find 7.4, that's 7.24. Okay, this one. So follow that line up, see where it hits around there, and just read that. Okay, first of all. Now you want greater. Remember, it says weight greater than 7.4. Greater than 7.4 is everything that way, which means if it's everything this way, it's going to be everything that way. Okay, so whatever this number is, I believe it is, what was it again? Let's look back. Okay, I think it's 51 to, 51. So it's everything 51 and greater, okay, which is 9. The gap there to 60 is 9. So 51 and greater is 9. Okay, so the number of parcels are 9. There are 9 parcels with a weight greater than 7.4 kilograms. All right, question number 12 now. 12. F is inversely proportional to D squared. Let's write that down. Inverse proportional, F is equal to 1 or K over D squared. So F equals 3.5 when D is equal to 8. So K over 8 squared. Find K now. So it's going to be 3.5 times by 8 squared. That is K. And then K would be equal to 3.5 times by 64. And that gives me 224. So now we found the value of K. Go back in here and substitute it there. So therefore the equation that you have is going to be F is equal to 224 divided by D squared. That's the answer for part A. Now find the positive value of D when F is equal to 10. So using this, plug in F as 10. So you're going to have 10 is equal to 224 divided by D squared. Move the D up there, but move the 10 down there. So they kind of swap. So you have D squared is equal to 224 divided by 10. D squared is equal to 22.4. And then D would be equal to the square root. You have a plus and minus, by the way, 22.4. And that gives us a plus and minus 4.73. But remember, you want the positive value. So therefore, the positive value would be 4.73. So 4.73 is your answer. Okay, inequalities now, huh? Okay. So shade the region of R that satisfies all of the following inequalities. Let's look at these lines first, all right? So all of these lines, let's look at that. So this one, we need to think of x equals 2. We're going to draw the line x equals 2, okay? This one, we're going to think of the line y equals minus 3, which is like that. Oh, sorry, not like that. It's like that, yeah? X equals 2 would be like that, okay? This one, we have to draw a straight line graph, y equals 2x plus 1. The gradient is 2, the y-intercept is 1. We're going to go through them step by step. But this one, we can't see it, yeah? We can make it y equals mx plus c. It's probably easier. So if you make y the subject, so if we have 2y is less than 6 minus 3x, and then we divide by 2. So we have y is less than 6 divided by 2 is 3, minus 3 divided by 3 over 2. X there. That's the equation, okay? Or you could write it as minus 3 over 2x plus 3, if you want it in the form y equals mx plus 3, okay? Now let's start with this one first. So that was x equals 2. We need to draw the line x equals 2, which is going to be a line like that, okay? So that is the line x equals 2. So I'm just going to label it. X is less than or equal to 2, but we don't write equals to, remember that. Yeah, that would just help us. Now, that's that one done. Y equals 3. So y equals 3, minus 3, sorry. Yeah, there. So we write here, y is greater than or equal to minus 3. This one here, it's a straight line. Y equals mx plus c. The y-intercept is 1. So it starts here, and the gradient is 2. Now, the best way to get the gradient is, remember, gradient is equal to y over x. We want the gradient to be 2. So we want 2 over 1. So along for the x, we want 1. And on the y, we want 2. So along by 1, up by 2. Along by 1, up by 2. Like that. Yeah. So these are the points you want to make a marking of. So here, it starts on 1, because it cuts the y-axis, and goes along the x by 1 up by 2. Okay, along the x by 1 up by 2, right here. And then you can just get your ruler once you've done a few points like that and mark the rest in itself, like this. Okay, all right, that's a bit long now. And that was y is less than or equal to 2x plus 1. Right, the last one, which is this version, let's use that one. Again, it cuts the y-axis at 3, but it's got a negative gradient, okay? Once again, see that negative gradient? Remember what I said? The gradient, m, is minus 3 over 2. So the x is 2, and the y is 3, right? It's a negative, remember that, yeah? So it goes down, right? But we start at 3, right here, and we go across the x by 2, so 2, and down by 3, like that. Okay, so from there to there. All right, we've got 2 points there. So, oh, sorry, we won't have a negative gradient then, would we? We'd have a positive gradient. Hold on, go the other way. That way, and then that way. Okay, by 3, like that. So, oh, why am I saying on plus 3 here? Minus 3. I'm supposed to start on plus 3. Okay, here, plus 3. There. Right, so across, down, 3. Can you see? Across by 2, down by 3. That's where you get your negative gradient. Yeah, x is 2 and y is 3. And we can do that again. Across by 2, down by 3. All right, these are the points that you want to mark. Once you've marked a few, you can do the rest with a ruler. You don't need to do it forever. Just join them up like that. There we go. Oops, did I not do that? There. Okay, so that's your line. Y is, okay, you know what another thing is? Yeah, just make sure that you write this version. Okay, it's the same, but just in case you get confused. All right, so just write that version so you remember it. So 3x plus 2y less than or equal to 6. Right, now comes shading. Now it says shade the region R. What I do, because you just have to identify the region R. One of my students asked me this. They said, oh, what about if I shade the region? I get confused with this method. Look, as long as you identify it by writing R, okay, that's what you need to do. Now, why I mentioned this is because if you look at this one, I shade the part we don't need, all right? So here it says x is less than 2. So if you go back to that line, it was here, yeah? Where is it that x is less than 2? X is less than 2 this way from that line. These are all the values of x which are less than 2. We want that part. We don't want this. So I'm going to shade out the part that we don't want. Can you see? I'm shading that out. I don't care about the other lines. We'll look at those other lines in a bit. If I've gone over it, don't worry. Then look at this. Yeah, this is y is equal to minus 3. Where is that line? Right there. Not equal to. Y is greater than minus 3. What do we want? We want values of y greater than minus 3. Where are they? They are up there. Okay? We want that. We don't want this. So I'm going to shade that out. There, I'm going to shade it all out. Again, I'm going over the other lines. I don't care about that. It's okay. Next, look at this. We want what? Y is less than. Yeah? Now, you can watch my inequalities videos for more details about this. Yeah? But when it comes to these situations, I mean, these were straightforward, what you can see. But when it's less than, you want below the line. When it's greater than, which you're going to see here, is y. Oh, that's still less than, actually. Yeah, but it's above the line. Anyway, when it's y is less than, you want below the line. But watch my inequalities video on my channel for a bit more detail about that. Okay, so where's that line, by the way? There. Okay, this was the line. We want below the line because it's y is less than. We want that. So we don't want this part. Shade it out. Okay, we don't want that part. Shade it out. Just follow that line. Don't worry about the other lines. Okay. Finally, the last line that we have here, look at this version of it. It says y is less than. We want below the line. This part is below the line. We don't want above the line. Shade it out. There. Now, can you see there's a region that has been left unshaded right there in the middle? That is your region. And just mark that with an R. If I was an examiner, I'm looking at this, I can see that you've done it. You've identified the region. You've marked it R. So whether you shade inside or outside, it doesn't matter as long as you can easily identify it. And exam marking guidance allows it. I've seen it. Okay, so don't worry. Okay, moving on. Question number 14 now. What's this? Acceleration of the car when t equals 5 shown when you're working. So here you want to go to find 5 right there. Okay. And then you want to draw a tangent to this. Okay. So I'll show you how I'll draw my tangent. So I know the marking is right here. So a tangent. You want to draw a tangent right there. Like some of you might think, oh, well, how is my tangent? What if it's not great? It's an estimate. Look, estimate. All right. Just make it good. All right. This is not a tangent. It goes over the line twice. All right. So just relax. Just draw a tangent, okay, as best as you can. All right, as examiners, yeah, and you can go through as much as possible. It doesn't matter. I said That's a like gap. That's not even a proper. Look at me getting so worried. Yeah, that's better. Just as long as it touches it once, all right? Now, what do? You need to find the gradient of that tangent that you drew. And you know what? You can draw small triangles. You can draw big triangles. But remember what I said about triangles? With these ones, you can't, you don't want to go halfway in the box like there. You want to go like here, from the corners, exact corners. But this one is a bit messy. You know what? I'll do, look at that. That's a nice corner. And look at that. That's a nice corner. Look at that. Look at that. Oof, look at that. Exactly on the corner. Exactly on the corner. Yeah. So I'm going to make a huge triangle from there to there like that. Yeah. I want to make that. And I'm going to find the gap of the y and the x. And it's easy to find the y because this is exactly here, which is, what's that? So that's 15. That's 20. Every 2 must be 1. So 16, 17, 18. So that's an 18. All right. So I know the height there, all of that is 18, the gap there. Yeah. And the same thing here, that's 6, that's 7, and that's 8. So therefore, if that's 7, each one must be 0.2. So 0.6, 0.4, 0.6, 6, what am I saying? 6.2, 6.4, 6.6, 6.8, 7, 7.2, 7.4. Okay, so that's 7.4. So if I'm working out m, y divided by x, for the y, I've got 18 divided by 7.4. Stick that in my calculator. 18 divided by 7.4 has a gradient of 2.43. Okay, so the acceleration is 2.43 meters per second squared. Okay, and it is a deceleration actually. Yeah, that is something as well, because look, the speed was 25, it's gone down. So although it's acceleration, because the speed's gone down, all right, it's actually a deceleration. All that means it's going to be a negative gradient. Okay, so there, that's it. So it's minus 2.43. Okay, and again, there'll be a range of values that you can accept, all right? But just remember, it's a minus, please. I don't think you'll get the full 3 marks if you wrote 2.43. Okay, because that's an acceleration, positive. Okay, it's a bit confusing. It says estimate the acceleration, but it is a negative value you should give because it's a negative velocity from 25, not negative velocity, it's at 25 to 0. It's gone down, the speed, which is a deceleration. It's slowed down. Okay, then it says work out an estimate for the distance the car travels in the first 6 seconds after it slows down and use 3 strips of equal width. Now, for this, let me just do one thing. I'm going to delete this because I need the graph without that on it. I want to show you what I'm going to do. All right, so here, if you look at this, it says I use 3 equal strips. Okay, so between 0 to 10, I have to somehow, is it, how many seconds? First 6 seconds, sorry, not 10. I don't need to go through all of it. All right, so between 0 and 6. So between there and there, and to break it up into 3 strips, okay? 3 strips of a shape. So 2 is 1 there. This 4. And then, of course, our 6. Now, look at the shapes it's created. Yeah, I'm going to make this. Yeah, that's a trapezium. That's also a trapezium. And that's also a trapezium. Now, with the others, they were quite more or less on the line, but they are straight lines now, yeah? But this one, we've got a little bit over, which is going to affect what you do later, okay, about overestimate and underestimate. But it's trapezium, okay? So we just need to find the area of the trapezium. So if you look at the first one's height is 25. Let me draw them for you. That's the first one, plus the second one, plus the last one. Okay, and the first one's height here is 25. The height here, I don't want to use the word height, length, let's say. So 25, and this one is, what did we say? Each one was 16. Yes, so that's 16. Okay, that's 16. The second one here is this one. That's also going to be the same 16 here, and as it was here, yeah? So 16, we just need to find this one. So that one, zoom in a little bit, 8. Yeah, 8. That 8 is also going to be on the other side. And then this one here, yeah, that one. That one is 4. Now the height of all of them, the actual height, because it's like sideways, is 2. You see, it's 2. The height of all of them is 2. So what's the area of a trapezium? The first one is going to be the 2 parallel sides added, 25 plus 16, times by the h divided by 2. The second one is going to be 16 plus 8 divided by 2, or times by the height, whichever way you do it, it doesn't matter. And the last one is going to be 8 plus 4 times by the height divided by 2. So essentially they cancel anyway. All of the 2's will cancel. So you're literally doing 25 plus 16, which is 41. 16 plus 8, which is 24. And 8 plus 4 is 12. You're adding them together. So plus 41, 24 plus 12. And you get 77. And yeah, there's a range between... Oh, hold on a minute. Let me just do that calculation again. 16 plus 8, 24. Yep. Plus 12, 77. Yeah, there you go, meters. Yeah, done. So the range was like between 76, 80-ish. It's fine. Okay, if you've done that. Right. Next, 15. Given that a is a prime number, rationalize the denominator of that. Okay, so rationalize means to multiply top and bottom by that. Okay, I don't know what the prime number bit is, but we'll see in a bit. So 1 over root a plus 1. What do we multiply the top and bottom by? Root a minus 1. Okay, so multiply the top and bottom by the minus version. So if we multiply that out, let's make some room. Let's take up too much space. We get root a on the top minus 1, or on the bottom, we get root a times root a, which is just a. And then we have that times that, which is minus root a. Then we do this times that, which is a positive root a, and they will cancel. And then minus 1 times minus 1 is minus 1. So yep, they do cancel. So you end up getting root a minus 1 over a minus 1. And that's it. That's your answer. Okay, so root a minus 1 over a minus 1. And a is a prime number. That means it can't be broken down. That's what it means. Like root a can't be broken down any further. That's what it means. Okay. Question number 16. Right, okay, solve quadratic here, yeah? Okay, so we know the value of this is 3 over 4. Some students, yeah, they expand this out. And yeah, just have to come back to this otherwise, yeah? These are limits, by the way. These are not equal to that exactly. But we're using them so we can draw the quadratic graph. We've got minus 5 here. We've got 3 over 4 there. And it's going to be, for x squared is going to be positive, so it's going to be a smiley graph. If you want more help on this topic, you can go to my channel, and there's videos there where I explain that. So it's going to be a smiley graph like that. And what are we looking for? Right, so all of this is your y. So you have y is less than 0. So where's your y-axis here? Y, there's 0. You're looking for less than 0, which is this part. So you're looking for this. Yeah, this is your range of values. So it's going to be between, x is between, and we use the less than sign without the equal because that's what that is. So it's going to be 3 over 4, x is less than 3 over 4, or x is greater than minus 5. And they are your solutions solved. All right, next, number 17. We got 3 solid cylinders which are similar, made from the same materials. L has a mass of 64. M has a mass of 125. So let's write that down. 64 grams, 125 grams. And M also has a surface area of 144 centimeters squared. And P has a total surface area of 16 centimeters squared. What we don't have for P is its mass. Yeah, we don't have the mass of P. Okay, and we don't have the surface area of LL. Okay, we don't have the L surface area. Okay, right, now you have to identify length, area, volume from here. Mass, is it a length, area, or a volume? Mass is a volume. So all of these masses are your volume ratio. So can you see between L and M, you've got that ratio. Yeah, complete. And they're still similar, so you can use P to deal with it in a second. And the surface area is given to you. Yeah, so you know that these are the area ratio. Now we need to work at the height of each one and put it into that ratio, which means we need to go to the length ratio at some point. Okay, so let's start off with like comparing L to M and put 64 grams and 125 grams. This we know is our volume ratio. You can simplify 64 and 125 to make life easier for you if you want, but it's not necessary because you need to go down to length ratio anyway, and these numbers are nice numbers. So how do you go down to length ratio? You cube root 64, cube root 125. Cube root of 64 is 4, 125 cube root is that. So that is your length ratio between L and M. Then use M and P and this, which is your area. Okay, so between M and P, you've been given 144 centimeters squared and 16 centimeters squared. And this is your area ratio. Now, how do you get from area ratio to length ratio? You square it, square root. And that gives you 12 and 4. And that's your length ratio. Now can you see you've got L and M length ratio and M and P's length ratio. If you put them together, so if you have L, M, and P, so if you have for the first one L and M 4 to 5, and the next one M and P, but doing another line 12 and 4, the commonality is this one. So 5 and 12, what do they both have as the lowest common multiple? 60. Let's just go 60 actually. Yeah, it's fine. 60. Yeah, 60. I was just thinking I could have simplified this further. That's why. Because I looked at my solutions I did, and I had simplified it much less. And then it was a different number, the lowest common multiple. But here, just keep it as is. Let's say you haven't simplified 60, yeah? And you have a calculator anyway. How does 12 become 60? You times by 5. How does 5 become 60? You times by 12. So therefore, you need to times this one by also 5. So 4 times 5 gives you 20. And you need to multiply this one by 12. 4 times 12 is 48. Okay, so now you've got the height of L, M, and P. 48, 60, and 20. But do you want to simplify it? Yes. What can you simplify all of those numbers by? You can divide by 2. Let's just go with 2 for now, yeah? So that's 24, 30, 10. And then divide by 2 again. 12, 15, and 5. I think that's the lowest. There you go. So 12, 15, and 5. Now, this particular question doesn't actually say give it in your simplest form, does it? So I'm assuming this is going to be fine as well. All right, so whichever stage you did it, because it doesn't say give it in your simplest form. So you'll get all the marks there. Okay, question number 18. There are 4 red, 3 yellow, and 1 green in a bag. Counters. Tom takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red in the bag. You must show you're working right. Let's just break this down. We've got probability of a red. What's the probability of a red? There's 4 reds out of the total. What's the total? 4 plus 3, 7 plus 1, 8. 4 out of 8. Probability of a yellow. What's the probability of a yellow counter? 3 out of 8. And the probability of a green counter is 1 out of 8. Okay. All right, 4, 3, 7, 8. Yeah. Right. Now he takes at random 3 counters from the bag. Look at the probability that there are now more yellow counters than red counters. Now, if you're taking out 3 counters and you're not replacing it, by the way, remember that, because it doesn't say anything about replacing. So don't assume things. You're not replacing. We want to work out the probability that there are more yellow counters than red left in the bag. All right. So let's look at all the possibilities that you can have of 3 counters. So we can have a red, and a red. Those 3 counters that we pick can be a red and a red and a red. What does this? We could be, let's do all of them actually. Red, we can have the second counter also red, and the last counter being green, okay? Or we can have a red and a yellow as the last counter. Okay, can you see? We've done all the possibilities where the first one is a red, second one is a red, but the last one is red, green, or yellow, right? We did this because red has 4 counters, all right? So that's why we can have up to 3 reds in a row, okay? We'll still have a red left, okay? So this one still has, so let's see what it has, this one left. So if we take this possibility, we've taken out 3 red counters, we had 4 to start with, so we've got 1 red left, okay? And all the yellows, so 3 yellows, and 1 green, because we haven't touched green here, okay? On this combination, we've got 2 reds, so we're going to have out the 2, how many reds left? We've taken out 2, we're going to have 2 red left. We're going to have all 3 yellows and no greens. Okay, you see the possibilities, why I list them like that? And on this one, we've taken out 2 reds, so we're going to have 2 red left, and we've taken out yellow this case. So yellow, there was 3 of them, we've got now 2 left, 2 yellow left, and we've got 1 green. Okay, so let's look at what you want. There are now more yellow than red. Well, if you look at it, 3 yellows, 1 red. So this is a possibility that we want. We want that possibility. Because if you look at this one, you've got 2 red, 3 yellows. Again, actually, we want that too. Okay, but this one is equal. You can see the number of counters left is equal. 2 yellows, 2 red. There is no more yellows than red. So we don't want that one. Okay, that's not one that we want. Let's look at more combinations though. There's plenty more to do. Let's say we pick the first one as a yellow counter, and yellow counter, all 3 yellows. So all 3 yellows, no more yellows left. So all the reds are left. So 4 red, 0 yellow, 1 green. So let's look at that possibility. Do we have more yellow than red? No. Okay, so we don't want that anyway. All right, next one. Let's have 2 yellows and the last one being a red. We're going to go systematically here, yeah? So with 2 yellows and the last one being a red, that means we've got 3 reds now. 2 yellows taken, so 1 yellow left from the 3 that we had, and 1 green. In this example, again, is yellow more than red? No, it's not, so we don't want that. Yeah, we want the tick ones. We're going to work out the tick ones in a bit, okay? Next, we have yellow, but let's say the last one is a green. So what do we have left in the bag? Reds have been untouched, so we have 4 reds. How many? 2 yellows have gone here. So 2 from the 3 yellows that you had, so therefore 1 yellow. Again, we don't even need to look at it anymore, and the green's 0. It's just, yeah, we know that there's not more yellows than greens, so we don't want that. So that's the yellow choices, isn't it? Yeah, but we can, remember, what we can do, we can move across as well, okay? Like, for example, we could have done red and then a yellow and then a red as well. We can have that option too. Just remember that. Okay, but it's the final thing that we're most interested in, okay? Okay, so I'm just going through my list. Right, now, right, with the green, there's no point doing the green because the moment you pick the first green, yeah, it's gone. All the greens are gone. You can't pick a second green and a third green and a fourth green, okay? Nothing like that. So we just want all the possibilities where you're left with more yellows than red, okay? So we've got this one, we've got this one. This is pointless, this is pointless, this is pointless, okay? So basically, to be left with more yellows than more reds, we can only take it out 1 yellow once. Yeah, we can only take out 1 yellow, all right? Because if we take 2 yellows out, we've got 1 left, and we've only got 1 more pick left, and we can only pick 1 red. So, you know, it has to be where we take more reds. So, yeah, but I just want to exhaust all the events so that you can actually see what's going on. Right, I did say to you we're going to move some of these, yeah? So red, sorry, not that one. Let's say green. We could have picked a green here, and we could also have this situation, which is not a problem. So the second pick was a green. Or we can make the first pick a green and then 2 reds. Okay, so it's this whole thing. We can get that 3 times. We can have that 3 times, depending on where you put the green. You can have the green at the end, you can have the green in the middle, or you can have the green at the beginning. So you get that 3 times. Okay, I'm just going to make a mark here that this is going to be 3 times as much. Okay, we've got 3 of these. Where else? It's this other situation here. So 1 red left. Okay, that's fine. Okay, so we basically got that plus 3 of those, and that's it. Okay, that's our combination. Now, any other combination doesn't work. It doesn't matter if you move this over here or red first. Yeah, it will still be this thing left overall. So it doesn't really matter. And if you start going for the greens, yeah, once you pick 1 green out, then you can have red. The moment you let's do that so I can show you. Yeah, green, red, because you can't have 3 greens. What does that leave us with? Let's see. And green, yellow. Okay, and what else? That's it. You can't have any more because you can't pick any more. Or you can have, sorry, you can have one more. You can have green, red, and yellow. All right, let's have a look to see what these combinations leave us with. So you can actually just exhaust the list. So green, red. So if you look at the original, how many reds will be left? You've taken out 2, so 2 reds. How many yellows? None. So you've taken out none, so you still have 3 yellows and 0 green. So can you see? We don't want that because, actually, we do want that, don't we? There. But that's going to be handled here. Remember that, because that's the position of that changing. Yeah, that's why this is going to be handled here. The next one, we have got 1 green and 2 yellows gone. So the reds are untouched, so 4 red and 2 yellows gone, which means 1 yellow left and 0 green. And we don't want that anyway. And the last one, green, red, and yellow, 1 of each color. So 1 red less, which means 3 red, 1 yellow less, which means 2, which we don't want that straight away, and 0 green. We don't want that straight away. So, and the last one, did I do the last one? Green, yellow, red. Yeah, okay. Where's this one? I said there's another version of this. So we put the green here. So red, green, red. Okay, yeah, we've got it covered. It's covered. It's done. These are all the green ones exhausted. Right, so we want this and this 3 times, and that will cover this as well. Please don't add this again, okay, because that's already there. Red and 2 reds and 1 green. It's already covered in there in a different order. All right, so we want R, or 3 lots of R, G, which would be the same probabilities anyway. Okay, we want that. So for the red, we had 4/8 times the next one would be 3/7 times the next one would be 2/6 because it reduces by 1. And then 3 lots of that. Red is 4/8 times 3/7 times 1 green, 1/6. Okay, so there we go. Now it's a calculator, so we're going to do 4 times 3 times 2, 24/8 times 7 times 6, 3, 3, 6, plus 3 lots of 4 times 3, which times 1, which is 12, and then 8 times 7 times 6, 3, 3, 6. I'm going to multiply those two together. Let's make some room here. Multiply those two together, so 3 times 12, which is 24 over 3, 3, 6, plus 36 over 3, 3, 6. Add the two numbers on the top. We get 60 over 3, 3, 6. If we can simplify this, 60 over 3, 3, 6 is 5 out of 28. And that's your final answer, 5 out of 28, or 60 over 3, 3, 6. All right, so for this next question, we have a quadrilateral, OACB. M is the midpoint of O to A, and N is the midpoint, not N is the midpoint, N is the point on BC, such that B to N and N to C is in the ratio of 4 to 5. So what we can do, we can say this is 4, this is 5, so in total this is 9 parts. O to A is equal to A, so we have that is A. O to B here is B, and A to C is K lots of B, where K is a positive integer. Okay, so these are parallel. It's just K means it's a different magnitude to O to B. Express Mn in terms of K, A, and B in its simplest form. So M to N, we need to find M to N. So how do we get from here to here? Okay, we've got two routes. We can go this way, or we can go that way. Okay, but we are going to go from, let's go that way. Yeah, from there to there. That way we use KB, because if we use this one, we won't use KB because it says find it in terms of K, A, and B. That's why. All right, so we're going to go that way. So M to O plus O to B plus B to N. M to O is half of this. Okay, but it's going backwards, remember. So it's minus A going backwards. So M to O is half minus a half A. O to B is just B plus B to N. B to N is 4 out of the 9 parts of BC. Okay, so it's 4 out of the 9 parts of B to C. Now we need to find BC because we don't have BC. So go to the side here and find B to C. So how do we get from there to there? We can't go that way. We have to go that way all the way around. Oh, hang on. I just remembered. Having said to you guys that we go this way and we don't get that. We didn't get that, but now we do get that because to find BC, we have to go all the way around. Yeah, sorry. I just realized what I said there, but we were good. We were good. Right, so BC. BC is going to be BO plus OA plus AC. So BO is going to be back against this, so it's minus B. OA is going to be A plus A, and AC is going to be KB. If we now collect the like terms, okay, can't really collect like terms, so what we can do is KB minus B like that. We can put it like that, and then we can factorize out the B. So we can have K minus 1B. All right, so I've just factorized out the B. All right, so if you expand this out, you'll still get this. Okay, just check that. All right, and that's B to C. We can also use this version as well, just to make it simpler. So we'll see what we use here when we go there. Right there. Actually, I might use that version for now. Okay, so minus minus a half A plus B plus, let's use that version. Okay, right there. So it's going to be 4/9 of A plus KB minus B. And now we need to expand that out. So we've got minus a half A plus B plus 4 out of 9A plus 4K over 9B. So it's just this multiplied by that to give me that. And then minus 4 out of 9B. Now, can you see you've got B here? Right, let's put the A's and the B's together. So 4 out of 9, we're going to start with the positive A minus a half A plus B minus 4 over 9 B plus 4 over 9 KB. Now to factorize out everything, so we want A on the outside. So we have 4 over 9. Actually, do we do it? Okay, let's do it like that. Yeah. Okay, we don't even need to do that. Sorry. I'm just going to do that on a calculator. So 4 over 9 minus a half. So 4 over 9 minus a half minus 1 over 18. So this gives me minus 1 over 18A. And then we've got this 1B, take away 4 over 9. So 1, take away 4 over 9. That gives 5 over 9b plus 5 over 9b plus 4k over 9b. And we can factorize out the b here. So we can have 5 over 9 plus 4 over 9k b. And that is this. Okay, we've got a lot going on here. Let me just make this a bit smaller for room. Okay, there we go. All right, so this is m to n in the form of k, a, and b. All right, so you could either give this answer or this answer. Either of those are fine. It hasn't asked you for any specific form, so you're good. All right, so now is mn parallel to O to B? Well, we said that it would be because it uses a different magnitude. So it's a version of B. It's an amount of B, and this is B. So yes, they are parallel. So it's one marker. Yes, they are parallel because they have, did I spell that right? Parallel, because same direction, but different magnitude. There, okay, same direction, different magnitude. All right, moving on, question number 20 here. The curve C has the equation y equals that. Find the coordinates of the turning point. Now, usually if it's A-level maths, this will be differentiated and you do that, but you don't know about this stuff yet. So, and you don't need to right now. So to find the turning point, we need to complete the square on this. Okay, so when you complete the square in a particular form, like this, the turning point would be the minus p, let's have that as a positive, minus pq. That would be your turning point, that coordinate. So the value here, the opposite sign, of course, and whatever that is, that will be your turning point. So we are going to complete the square here. So if we have 2x squared minus 12x plus 7, and to complete the square, we need the x squared coefficient to be 1. So we're going to factorize out the 2, and we can just divide everything by 2. So that will be 6x. I'm going to leave the 7 out. You can keep the 7 in there. Sometimes I do, sometimes I don't. But here we're going to just leave it out. So we're just going to complete the square here. So this section here, I'm just going to take it to the side here and complete the square on it. So how do we complete the square? We take that coefficient, divide it by 2. So that becomes minus 3 squared. Take away the 3 squared. So that will be x minus 3 squared minus 9. And then we're going to put that back into there now. Okay, so it's going to be 2 bracket. And inside it's going to be x minus 3 squared minus 9, and then the plus 7, that's also outside the bracket there. Right, so we're going to now expand this out here and expand this. So that becomes 2 bracket x minus 3 squared. 2 times 9 is 18, plus the 7 that's loitering outside. And minus 18 plus 7 is minus 11. So now, if you look back at what I said, it's going to be this value, which is minus 3, but it's the opposite sign. So the turning point is going to be positive, and this value, which is here, as it is, so minus 11. So the turning point is 3 and minus 11. Okay, question number 21. All right, so we have the graph y equals g of x is shown on the grid. On the grid, draw the graph of, so it's a minus there and a plus there. So let's look at what happens to this shape in transformation wise. So this means it's a reflection in the y-axis. So that means here, this shape is reflected in the y-axis right there. So the reflection would be like something like that, yeah, on the other side. And then this means it goes up by 2. So after that thing that you saw here, it's going to go up by 2. So we just take one of those points and just move them up individually by 2. All right, so that's what we have to draw. Okay, so let's start off by doing the first reflection. So the first reflection in the line in the y-axis. So if you imagine this is a mirror line, this part is like that. There. Oops. There. And again, this is a mirror line, and we're going to reflect this part. This part is going to be reflected like, just going to keep the gap here. Sorry, the gap here is 3, isn't it? Yeah, so it's going to be 3 away. It's up to here. It's going to go here. So there. So that's the first part done. Then we're going to move this up by 2. Now to move it up by 2, oh, sorry, that hasn't been done properly. That needs to be there. There. Then it's going to go up by 2, yeah? So it's going to be up. That point is going to be there. These points are going to go up there. This point is going to go up there. So you end up having something like that. Okay, and that's your final version. So this is your g of x minus x plus 2. Okay, there you go. That's the graph you want. All right, question number 22. Okay, points on a circle. MAP and BP are tangents to the circle. So when you have a point outside the circle, makes tangent, then this will be broken up into congruent triangles. All right, so we can add that. That's one of the rules of circle theorems. Okay, oh, it's not going nicely, but it needs to be there. Okay, so we have a right angle here because a hypotenuse, a tangent meets a radius at 90 degrees right there. So we've got both of them have a right angle there. We need to prove that AP is equal to BP. So the proof is that side is equal to that side. Okay, we have to show that by one of the rules. Now, this is the hypotenuse of both. So they both have the same hypotenuse. They both have a right angle. Okay, they both have a right angle. And this is the radius of both of them, which is the same. So they have one side, which is the same. So they are congruent by the RHS rule. If these two triangles are congruent, then that means AP would be equal to BP. Okay, so AP would be equal to BP because they are congruent, because we've proved by using this rule that they are congruent triangles. Okay, so we have to show this. Now, how many marks is this? 4 marks. So we should really state those things. So we should say, for example, both have the same hypotenuse, which is OP. Both have right angles because tangent meets radius at 90 degrees, and both have same radii or radius. Okay, so AO is equal to OB. Okay, so therefore both triangles, I can't even spell anymore, triangles are congruent, exactly the same, by RHS, and AB, oh sorry, not AB, AP would be equal to BP. There you go, done. And we are done with the paper. Hope you enjoyed this walkthrough. Don't forget to give this video a thumbs up, and please do share it with your friends, people that might benefit from this. If you're a parent particularly, but I don't think you would have got this far. If you're a student, you must share it. Goodbye for now. See you in the next one.